Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be looking at Unit 2, Notes 3. So we're going to be solving systems using elimination. So we've been doing graphing up to this point. So this is a way you can algebraically solve to be able to manipulate and solve for specific problems and get an actual answer. So let's go ahead and let's take a look at this first one. So solving systems by elimination. So to do that, we cannot solve equations with two different variables, okay? That's just not possible. But there is a way we can do it when we have two equations, and that's elimination. So basically, we're going to have to make one equation with the variable, and we do that by combining the equations so that one of the variables is going to drop out. Now that just sounds like a lot of mumbo jumbo, so we're going to get going here in a second so you guys can take a look at how that's going to apply moving forward. So let's go ahead and let's take a look at our first example here. So what we want when we're looking for elimination, what I always look for is same number or same coefficient out front with an opposite sign. So if I look here for this one, I notice that the x has a positive 1 and a negative 1. Remember, if there's no number out front, then that number is 1. So now I really have x plus 2y is equal to 10, and then I have negative x minus y is equal to negative 6. So I just rewrote out that equation, and I notice that those two are the same. So once I have same number, opposite sign, I can go ahead and add down the columns. Well, when I do that, x minus x is going to cancel out. 2y minus y is just going to give me y, and then I end up getting 10 minus 6, which is 4. So now I know that y is equal to 4. So I'm just going to jot that up here because I'm going to have to erase some of my work here. Now let's go ahead and let's take a look at getting x. So now in order to get x, we're going to take this and we're going to plug it in for whichever y we want. It doesn't matter which equation you choose. What I do want to point out to you though is that this x is a 1. So since it's a 1x, I'm not going to have to do a lot of solving. So I'm going to choose to plug into this top equation. So I'm going to keep and plug in for that y. So everything else in the equation is going to stay the exact same. The only difference is I'm going to take the y out completely and I'm going to put the 4 in instead. So then I get x plus 6 is equal to, or plus 6 plus 8, if I could add, this would be a great day, is equal to a positive 10. Okay, this should have been a 10. Okay, so now I'm going to subtract 8 over to the other side. Well, 10 minus 8 is going to be 2. So here I get that x is equal to 2. So now I have a point. I have my x and I have my y. So there's actually a specific way that we write that out. Okay, so we're going to write it out as a coordinate point with first my x coordinate, which is 2, then my y coordinate, which is 4. So that's my answer right there for number 1. Now let's go ahead and take a look at number 2. So I notice on those y's, if you notice, you have the same number with opposite signs on those y's. So that means that I can go ahead and I can add down the columns right away. So 2x minus 3x, that's going to give me a negative x. Then the y and minus y are going to cancel out. And then I have 4 minus 8, which is going to be a negative 4. You could also look at that right there as plus a negative. That works as well. So now it's not solved for x because I have that negative on the outside. So that's the same as a negative 1. So I need to go ahead and divide both sides by a negative 1. So then I end up getting that x is equal to 4. So now that I know that x is equal to 4, I need to plug it into the system up above. So again, I can plug it into either one. Now recall that I'm looking for y. So I want to plug it into a formula where y is 1 to make it easier. So I'm going to plug it into this top equation right there. Okay, so then what we end up getting is I'm going to have the 2. Now instead of writing that x, I'm going to put that 4 down. And then plus y is equal to 4. So then I get 8 plus y is equal to 4. Then you go ahead and subtract 8 from both sides, and you get that y is equal to negative 4. So here are my two answers, negative 4 and 4. So we need to write that out as a coordinate point. So first thing I do is I write my x, and then I write my y. So I have 4 and negative 4. So that's my final answer for number 2. Let's continue moving forward. So let's take a look at number 3. Again, for number 3, I notice that I can add straight on down. Okay, so I'm going to go ahead and do that. So I'm going to add straight on down. So I notice that negative 2x plus 2x, that's going to cancel out because I have the same number with an opposite sign. Then I'm going to add down the columns here. 3y plus 2y is 5y. Negative 6 plus, negative 11 plus 6, well, that's going to give me a negative 5. So now I have that 5y is equal to a negative 5. So I'm going to go ahead and divide both sides by 5. And then I get that y is equal to a negative 1. So now that I know what y is, I'm going to pick one of these equations to plug it into. Well, both the x's have a number in front of it, so it doesn't matter which equation you choose. You can always pick your equation. I just like to give you tips and tricks of which one to pick. So just for fun, I'm going to pick the bottom one. So everything in the bottom one is going to stay the same, except instead of having y, I'm going to put in a negative 1 instead. And that's going to be equal to 6. So then I have 2x minus 2, or you could write plus a negative 2, is equal to 6. So here I'm going to go ahead and add 2 to both sides. So then I get that 2x is equal to 8. Then I divide both sides by 2, and I get that x is equal to 4. So here I have two options. X is equal to 4, and y is equal to negative 1. Again, I need to write that out as a coordinate point. So I'm going to write that out. First my x, and then my y. So my answer here is 4 comma negative 1. Next, let's go ahead and let's take a look at number 4. So again, those y's are opposite, so I can go ahead and add down the columns. So 7x plus x is going to give me 8x. My y's will cancel out. 9 plus 7 is going to give me 16. So then I'm going to go ahead and I'm going to divide both sides by 8. So then I end up getting that x is equal to 2, and I can plug this into either one. I just want you to notice that that second one has a y that is positive. So to me, that's going to be easier to plug it in, but you really can plug it in to both. So what I'm going to do is I'm going to, instead of writing that x there, I'm going to put the 2 in instead. And then everything else in the equation is going to stay the same. So then I have 14 plus y is equal to 7. Subtract 14 from both sides, or that weird symbol, and then I end up getting that y is equal to negative 7. So here I have x is equal to 2 and y is equal to negative 7. So I need to write that out as a coordinate point. First my x, and then my y. Okay? Taking a look at number 5. Uh-oh. Okay, when I look at number 5, I'm like, yeah, my y's have the same number in front of them. What they don't have is opposite signs. So what I need to do here is to create some opposite signs. So I'm going to go ahead and do that. So I'm going to multiply one equation. It doesn't matter. You can pick the top or the bottom. And I'm going to multiply it by a negative 1. So that top equation, x plus y, is equal to 9. That's going to stay the same. Now the second equation, I'm going to change every single sign in there. So it's going to become a positive 7x plus a y is equal to a positive 7. Okay? So now I can go ahead and add down the columns, because if I were to write this out correctly, that should have been minus y. Okay, so those will cancel out. 7x plus x is going to give me 8x. 9 plus 7 is going to give me 16. So here, I'm going to divide both sides by 8. And I end up getting that x is equal to 2. So now I know that x is equal to 2, and I need to plug in to get my y. I can use my new version, or I can use any of the original versions. Well, I notice in my new version, I have a positive y, so I'm going to plug x into that one. So what I'm going to have is I'm going to take the x out and leave everything else. So I'm going to have 7. Instead of writing x, I'm going to write 2 plus y is equal to a positive 7. So then I get 14 plus y is equal to 7. So I'm going to go ahead and subtract 14 from both sides. And then I end up getting that y is equal to a -7. So that's my final answer for number 5. Same thing on number 6. I need to flip one and make it negative. So I'm going to keep this top one the same, and I'm going to change this bottom one by changing the signs of everything. Okay, so now I can go ahead and add down the columns. -4x plus 4x is going to cancel out. 2y minus 3y, that's going to give me the opposite of y. Some people say negative y. I like to say opposite of y. And then 8 minus 10 is going to give me a -2. Okay, so now I need to solve for y. So because of that negative out front, I need to divide both sides by a -1. And then I get that y is equal to a +2. So now I need to plug that back in. I can use my old versions or any of my new versions. So let's just plug it into the top one just for fun. So I have -4x, and then I'm going to take out that y, and I'm going to substitute in 2 instead. That's supposed to be a 2, and that's going to be equal to 8. So then I have -4x plus 8, or 8 is plus 4. Goodness, you know that whole multiplication thing? It's hard. 4 is equal to 8. So when you subtract 4 from both sides, you get -4x is equal to 4. Last but not least, you need to divide both sides by a -4. So then you end up getting x is equal to -1. So now we need to write our answer out as a coordinate point. First our x, then our y. So our point is -1, 2. It looks like I forgot to do that over here, so our point is 2, -7 over there. Okay, so let's go ahead and let's keep kind of moving through this. So we're going to do a word problem. It says the sum of two numbers is 12. Okay, the difference of the same two numbers is -4. Well, the sum of two numbers, let's have our numbers be x and y. So the sum, when you add those two numbers together, that's going to be equal to 12. The difference, okay, remember that difference means subtraction. So when you subtract those two numbers, you get -4. So now I see that my y's have opposites, so I can go ahead and add down the columns. So here I'm going to get 2x. 12 minus 4 is going to give me 8. So then I'm going to divide both sides by 2, and I end up getting that x is equal to 4. So now I can plug that into the other problem. Or either one of these. Okay, so I'm just going to plug it into the top one. So I know that x is equal to 4. So I'm going to take x out of here and write 4 instead. And then I'm going to have y, and then I'm going to have 12. So then we're going to subtract 4 from both sides, and I end up getting that y is equal to 8. If you were worried about your answer, you can always go ahead and check it. Do the two add to 12? Do the difference of them equal -4? And they do. So at this point, if you wanted to, you could pause the video and go and try the front sheet of your worksheet. Some students like to do it in chunks. So if you want to try the front side, we're going to continue next to work on something a little bit more challenging in regards to elimination. So here are the steps for solving systems by elimination. And I do suggest you write these down so that you have them if you get really, really stuck. So first thing you're going to do is to put both equations into standard form. And once they're in standard form, you're going to multiply one or both of the equations by an opposite number. Okay, then you're going to add the two equations together, and one of the variables should cancel. You're going to solve for the remaining variable, and you're going to substitute that in. We did a lot of that already. You don't need to write down everything. Write what you need to know to get this accomplished, okay? So let's take a look at some of these. So this one, again, that one's just going to be a simple making it a negative. So I'm going to go ahead, and I'm going to multiply that bottom one by a -1. So I have x plus 2y is equal to 10, and then I'm going to change and make this one, everything including what's on the other side of the equal sign, a negative. So now my x's will cancel out, so I just have y. When I do 2y minus y, I just get y. 10 minus 6 is 4. So now I need to plug that into either one of the equations. I think I'm just going to plug it into that one because that looks the easiest. But again, it's ultimately your choice. So now I have x plus 4 is equal to 6. Then subtract 4 from both sides, and I end up getting that x is equal to 2. So then I get 2, 6 as my point. Again, first my x, then my y. Or 6. Where did I get the 6 from? Sorry, the answer is 4. Come on, Miss Humber, get with the program. All right, so taking a look at number 2, I don't have opposites, and I don't even have the same number. So I have to create the same number, and I have to create opposites. So what I'm going to do is I'm going to multiply this bottom one. So I notice this is a 1. 1 is the easiest number to multiply, okay? So when I look at 2y, I'm thinking, okay, I need the opposite of 2y. What's the opposite of 2y? Negative 2y. And what do I need to multiply 1 by to get to negative 2? I need to multiply it by 2. So I'm going to multiply that entire bottom by a negative 2, including what's on the equal sign. So now this one kind of doesn't exist, and we're focusing on that top one and the one I just wrote. So 4x minus 6x is a negative 2x. 2y's are going to cancel, and then 8 minus 16 is going to give me a negative 8. Divide both sides by negative 2 so we can solve for that x, and we get 4. Okay, so that's our x value. Again, you can pick any of those equations to plug it back in for y, okay? I'm going to choose the top one because I think that'll be the easiest. So let's go ahead and do that. So I have 4, and then I just found out that my y is my x is equal to 4, so I'm going to plug that in. And then plus 2y is equal to 8. So then I have 16 plus 2y is equal to 8. Subtract 16 from both sides, and I get 2y is equal to a negative 8. Divide both sides by 2, and I get that y is equal to a negative 4. So my answers are 4, negative 4. Since my x is 4, that goes first. And then I'm going to go ahead and tack on that negative 4. Okay? So then, taking a look at number 3, solving by elimination. So I don't have any 1s. In fact, I had these 10s on the bottom. But I do notice that my y's already have opposites. So I'm going to ask myself, how can I create that opposite? What can I do to make them be the same number? So I'm thinking, what's the smallest number that 3 and 10 multiply to? And the smallest number that they multiply to is actually 30. So I'm going to go ahead and I'm going to multiply this guy by 10, and I'm going to multiply this guy by 3. And I'm going to go ahead and distribute that in. So here I'm going to end up with 20x minus 30y is equal to 110. Okay, then on the bottom I'm going to have 30x plus 30y is equal to 90. So then I can go ahead and I can add down the columns because these are going to cancel out. So 20x plus 30x is going to give me 50x. 110 plus 90 is going to give me 200. So now to solve for x, I'm going to divide both sides by 50. So here I end up getting that x is equal to 4. So we're going to need to remember that as we go into the next part of the problem. Now remember, you can use your new version or you can use the original when you plug it back in. It doesn't really matter. I'm just going to do this one because it has smaller numbers. So remember that I determined that my x was equal to 4. So I'm going to take x out and I'm going to put 4 in instead. And then the rest of that top equation is going to stay the same. So then I have 8 minus 3y is equal to 11. Subtract 8 from both sides, and I get that 3y, or a negative 3y, pardon, is equal to 3. Divide both sides by a negative 3. Oh, time for lunch. And that's going to be a negative 1. So that's my x. So my y is 4, or my x is 4, so that goes first, and then my y is going to be a negative 1. Okay, now let's take a look at number 4. So I noticed that these two are very similar. We don't have opposites, but I'm thinking, okay, you know what? I can multiply 4 by something to get it to be 12. In fact, I can multiply 4 by 3, and that'll be 12. However, we don't have our opposites. So what I'm going to do is I'm going to be multiplying by a negative 3 so that I can create those opposites. So then I'm going to get a negative 15x plus 12y is equal to 30 times a negative 3 is negative 90. Okay, and then that second equation I'm going to have stay the same. So you notice my y's are going to cancel, so that's a good sign. Then I have negative 15x plus 12x, so that's going to give me 3x. Okay, and then negative 90 plus 96, that's going to be 6. So now I'm going to solve that equation for x. I'm dividing both sides by 3, and I get that x is equal to 2. So now we're going to have to plug that back in so that we can get our y. To me, the original top equation is going to be the easiest. Okay, so I have 5, and I found out that my x was going to be a negative 2. Okay, then minus 4y is equal to 30. So then I get negative 10 minus 4y is equal to 30. So I'm going to go ahead and add 10 to both sides. So when I do that, I get negative 4y is equal to 40. Divide both sides by a negative 4, and I end up getting that y is equal to a negative 10. So my x is a negative 2, and my y is a negative 10. So that's my coordinate point and my final answer. All right, let's go ahead and let's take a look at number 5. So this one's solving by elimination. I don't have same numbers, but I do have opposite signs on the ends. So what I'm going to do is I'm going to make them be the same number. So what's the smallest number that 3 and 5 both multiply to? Well, that's going to be 15. So in order for 5 to multiply to 15, I need to multiply by 3. In order for 3 to multiply to 15, I need to multiply by 5. So now I'm going to go ahead and distribute those so I can get a brand new equation. So I'm going to get 10m plus 5n or 15n, sorry, is equal to 15. And then I'm going to get 3m, oops, sorry, I need to multiply that by 5. So then I'm going to get 15m, maybe, minus 15n is equal to 5 times 24, which is going to give me 120. Okay, so now I notice that my n's are going to cancel out. Well, 10m plus 10m, oh, that should be 30m. I forgot to multiply that by 3. I apologize. 30m plus 15m is going to give me 45m. And then 15 plus 120, well, that's going to give me 135. So I'm going to go ahead and divide both sides by 45. Now, when I do that, I get that m is equal to 3. So now I know that m is equal to 3, so I can go ahead and I can plug that back in to get the n. And I'm going to use the original second equation just for something different. So now I know that m is equal to 3, so I can take m out and put 3 in instead. Minus 3n is equal to 24. Okay, so then I get 9 minus 3n is equal to 24. So when I subtract 9 from both sides, and lunch is over, I end up getting 24 minus 9, which is going to give me 15. Divide both sides by a negative 3, and I get that n is equal to a negative 5. Now, this isn't an x, y coordinate, so what I suggest students do is you can just write it in alphabetical order in the point. So that's 3, negative 5 as your answer. Okay, so taking a look at number 6. Number 6 can get a little tricky. So I notice that my y's have opposites, but I don't know what the number is that they both multiply to. You could multiply the top equation by 9 and the bottom equation by 21, but then you're going to get really big numbers. So then I just started playing around with numbers, thinking, okay, what's going to multiply so that they have the same number? And I found out that they're both multiply to 63. So then I can multiply this top equation by 3 and this bottom equation by 7. So let's go ahead and do that. So when I multiply the top equation by 3, I end up getting 42x plus 63y is equal to 42. Okay, then I get, on the bottom, when I multiply by 7, I get 21x minus 63y is equal to negative 306. Okay, so what I need to do next is I need to add down those columns. Well, 42 plus 21 is going to give me 63. Okay, 63x. And then when I add, so this is negative, so it's going to be negative 306 plus 42. That's going to give me a negative 264. So now to solve for x, I need to divide both sides by 63. Okay, and I messed up somewhere. Where did I mess up? Okay, well, we'll just skip this one because I don't know where I messed up. So you can just go ahead and skip this one. If you know how I messed up, please come let me know. And then we will continue working on some of those word problems so I don't waste any more of your time trying to figure that out. So let's go ahead and let's take a look at number 7. It says that Dante spent $11.25 on 3 new, which I'm going to call X, and 4 old, which I'm going to call Y, comic books. Samantha spent $15.75 on 10 old and 3 new. Now remember I said that old was Y. Whoops. Old was Y and new was X. So let's go ahead and let's set that up. So let's just take this first sentence and set it up as an equation. Okay, so for every 3 new ones she buys at price X, and she buys 4 old ones at price Y, and that's equal to $11.25. Okay, then let's go ahead and take a look at the next one. She buys 3 new ones at price X, and then she buys 10 old ones at price Y, and that was $15.75. Okay, so what I notice here is that I have the same numbers on the top and the bottom. So all I'm going to do is multiply that second equation by a negative 1. So then I get negative 3x minus 10y is equal to a negative 15.75. So then this equation I don't really need anymore. Okay, so let's go ahead and we can add down the columns here. Well, the 3x and the negative 3x will cancel out. 4y minus 10y is a negative 6y. 1125 minus 1575 is going to give you a negative 4.5. Dividing both sides by a negative 6, you're going to end up dividing 2 negative numbers, which is going to become positive. So then you end up getting 75. Now remember that Y represents the old comic books, so that's the price for old comic books. So now I'm going to plug it back in up here to see what it costs for new. So I'm going to take my Y out and I'm going to put 75 cents in instead, and that needs to equal $11.25. So then here I get 3x, and then 4 times 0.75 is going to give me 3, and that's equal to $11.25. Okay, so we're going to subtract 3 to both sides, and then I get that 3x is equal to 11.25 minus 3, which is going to give me 8.25. Divide both sides by 3, and I get that x is equal to $2.75, so $2.75. So that's going to be for the new comic books. And that's your answer for number 7. Let's take a look at number 8. It says Amy walking in a straight path can be represented by the equation negative 2x plus y is equal to 3. And Kendra's walking a straight path at 3x is equal to, or 3y is equal to 6x plus 6. When are they going to be in the same place? Well, first of all, this works better when you have things in standard form, if you remember back to Unit 1. So Amy's good. She's already in standard form. We have 2x plus y is equal to 3. Kendra, however, we have to do some manipulating. We have 3y is equal to 6x plus 6. So what I'm going to have to do is subtract 6x from both sides. So then for this one, I end up getting 6x plus 3y is equal to 6. So now I need to make them match. So since this is a 1 here, to me it makes more sense to try and multiply for the y's. So I have positive 3y. What's the opposite of a positive 3y? That's going to be a negative 3. So I'm going to multiply that negative 1 by a negative 3. So then I get 6x minus 3y is equal to negative 9. And here I get negative 6x plus 3y is equal to 6. Add down the columns. That cancels. Oh, no. That cancels 2. So then I'm left with 0 is equal to negative 3. Well, what in the world? Okay, is 0 equal to negative 3? No, that's never going to happen. So this is a case where we have no solutions. Okay, so that means that they never cross each other, and you can write no solution as NS. That is perfectly okay with me. Last but not least, let's take a look at this one. A shipment of TVs, some weighing 30 pounds and others weighing 50 each, have a total of 880 pounds. I'm going to let X represent 30 pounds and Y represent the 50 pounds. So for every X 30-pound TVs, it weighs, well, 30 pounds. For every Y 50-pound TV, it weighs, well, 50 pounds. All of that together is going to give me 880 pounds. So then when you add all of those together, you end up getting 20 TVs. So then what I need to do is make these opposites. So I'm going to multiply this bottom one by a negative 30 so that I can cancel out my x's. So I end up getting a negative 30x minus 30y is equal to a negative 600. So then this guy is going to just disappear altogether. So we can go ahead and add down our columns. Our 30x's are going to cancel out. 50y minus 30y is 20y. 880 minus 600 is going to give us 280. Divide both sides by 20. And we end up getting that y is equal to 14 50-pound, that's supposed to be a 0, TVs. Okay, now we need to plug that back in. Well, if you remember, we originally had the equation x plus y is equal to 20. So we have 20 TVs altogether. If 14 of them are 50 pounds, how many of them are 30 pounds? Well, there's only 6 left. So x has to be 6 30-pound TVs. So that was just thinking logically. So that concludes your very long note video today. I know this stuff can be confusing, so please, please, please let me know if I can help you in any way. Thanks for listening.